Alright, we're doing Cat 1. This is, we're going to be talking about antiderivatives and indefinite integration. So it's not going to be that bad, I promise. I'll make it real easy for you. The first question we're going to answer here, well, it's not a question. We're going to find something. We're going to find an antiderivative, f of x, and this is the antiderivative of, and this is a small f here, of f of x is equal to 4x cubed. So let's get busy working some examples. We have f of x is equal to 4x cubed. Now I'm going to write over here, I'm going to write y is equal to x to the fourth. Now you should see some kind of relationship between these two, and that is, okay, let's go back to when we were taking derivatives in the previous section. Let's take the derivative of this right here. Well, the derivative is 4x to the third, right? Bring the 4 out front and subtract 1 from the exponent, and we have y prime. Well, guess what? And we're going to label this as our capital F here. That's what I meant to do. X to the fourth. I was about to rewrite it. Okay, well, it turns out that this is the antiderivative of f of x. So what are we doing here? We're going backwards. We're giving you this equation here, which happens to be a differential equation, and we're going back in reverse order. So we took derivatives going in this direction, but now we're going back in this direction. So in other words, you're given the derivative, and we're going to trace our way back to what the original function here was. So we call this the antiderivative, right? The derivative and the antiderivative. Okay. Now, if you remember, I said, you see this word right here? Okay. This word means that there's more than one antiderivative of f of x. So for example, the antiderivative could possibly be, here's another one. We'll label it as we'll label this as 1 and this one as 2. That's an antiderivative of f of x up here, or f of 3, we'll label this as f of 3 there. F sub 3, I should say. X to the fourth minus 10, let's say. And you're probably going, how is this an antiderivative of the small f of x? Well, once again, look back at what's going on here, okay, when we went in reverse order. What we're going to do is we're going to take the derivative, and I'll just do that right here. So to check if this is an antiderivative of our original up here, to check that, all we have to do is take the derivative of this. So in other words, I'm going to write f2 prime of x, and the derivative of this is 4x to the third. So on all of these, we're going to be able to take the derivative of the antiderivative to get back this function up here. Okay, so now hold on, what about this piece here? Well, this is a constant, and when you take the derivative of a constant, it's just 0. So that's the reason nothing's written over here. And of course, same thing goes with this. We got minus 10, but when we take the derivative of this constant, we get 0. So once again, this is going to be equal to 4x to the third when we take the derivative of this. So what could we say about this? Well, we could say this. We could say that the antiderivative, if you take the derivative of the antiderivative, you should get back what that original function was. Okay? So there you go. These two guys are equal. So when we solve these problems, when we take the derivative of them and we get back, right, this, then that means that we've done it correctly. So that's all there is to this entire section basically on integration, really. So let's work a problem here. I want to find the general solution of the differential equation y prime of 2. So we want to find the general solution. We want to find the general solution of this differential equation. So to begin, we need to find the function whose derivative is 2. And one such function is y is equal to 2x. So if we take the derivative of this, right, we get y prime is equal to 2. So there it is. Therefore, 2x is an antiderivative of 2. 2x is an antiderivative of 2. Let's look at the general solution of the differential equation. Well, the general solution would be y is equal to 2x plus c. This would be considered the general solution. And why is that? Well, we threw a c on here for constant because if we take the derivative of this, in other words, y prime is equal to, so the derivative of 2x is 2, but remember what the derivative of a constant is. The derivative of a constant is 0. Therefore, that's the reason we called this the general solution. Now, what's really interesting here is you could graph this and let C be 1, 2, 3, 4, 5, 6, and so forth, and you would end up getting just a bunch of parallel lines in the xy plane. So you ought to try doing that. How about some notation for antiderivatives. Here's some notation you should have seen in the past. This should be dy, over dx. That's a y up there. Dy over dx is equal to f of x. Alright. So this is a differential equation. It's just in this form here, but it's convenient. It's real convenient if we want to write this form into its differential form. So remember, in the previous section we talked about differentials. So yes, each one of these sections are connected. So this is the differential form, okay, of this differential equation. So the operation of finding all the solutions of this equation is called antidifferentiation, or sometimes we call it indefinite integration, and it is denoted by this sign. So see that right there? It looks like an S. But the general solution is denoted by this, so hang in there. So remember, when we take the antiderivative of this, we end up with not dy but y. Okay? And that's going to be equal to the integral. So this operator here says, okay, we're going to do some indefinite integration, f of x dx, and this is equal to, remember what this was, right, the antiderivative, and then there's our constant right here. Alright, so let's look at this here. This is known as the variable of integration, and this is called the integrand. This is known as the integrand. So I'm going to be repeating this stuff over and over again, and eventually you'll get it. And this is known as the constant of integration. So the integrand, right, the variable of integration, and of course this is the constant of integration. So we're going to work a ton of examples, and I promise you this stuff's going to get easier, and you'll be able to go take your test tomorrow and score an A, right? That's the whole idea here. Or if you're just doing this for a hobby, you know, impress your friends with it or something. Anyway, all right, let's move on. All right, antiderivatives and indefinite integrations is what this section is called. And we're going to find the general solution of the differential equation here. We're going to find the antiderivative of x. Right? So we got a differential equation and we're going to find its general solution. All right. We have dy over dx is equal to x. And we want to find the solution to this differential equation. What we're going to do is get it in that differential form. Dy is equal to x dx. And now what I'm going to do is I'm going to throw on this integral sign here. Oop. Now remember, this is called an indefinite integral, and we're going to be doing some definite integration, but this is called indefinite integration here. Now when we do that, we're really doing it to both sides, is really what's going on here. But the way I want you to look at this is, just for right now, is when we do this, this becomes y over here, okay? So pretend this is a 1 right here, and you're finding the indefinite integral with respect to y here. But when we do this, let's just say that we got a y right here, okay? Normally this would be a y plus c, and then you take the c to the other side, and a c plus c minus c, c plus c, whatever, you still get c. But, okay. Anyway, so this is where we're at. Now, just like when we found derivatives and we did the power rule, we got rules for doing integration, okay? And the way this works is, remember we subtracted 1 from the exponent, and this time we're going to add 1 to the exponent. So it's just the opposite. So we're going to add 1 to the exponent, and then we're going to take that exponent and put it down into the denominator. So a 2 goes here. Now, of course, remember, you cannot forget to put plus c here. If you forget this, it's going to be wrong, okay? So this is the general solution, right, to the differential equation, or this is the antiderivative of x. Write my x down, or my equal sign down here. All right, so this is one of the rules. You add to the exponent and then take the exponent and bring it down into the denominator. So this becomes x raised to the second power over 2 plus c is equal to y. Now, remember what I said. Okay, so we had dy over dx is equal to x. We said that we could, remember what I said, we could check our work if we want. We could check our work on all of these to see if we did them correctly. You know how to take derivatives, so all you have to do here is take the derivative of this. So bring the 2, bring it out front. It's over 2, and the derivative of a constant is 0. Now remember, we could write y prime here, or we could write dy over dx, whatever you want to do. So therefore this simplifies down to this, and therefore, as you can see, these guys are both equal. All right, they are both equal. So there you go. Then that is correct. This is a correct solution. All right, correct solution. Okay. I got a second here. Let's work another one. Let's say that we had y prime is equal to, let's say we had 2x, right? And so we want to find y, okay? And so what we're going to end up doing here is I'm just going to go ahead and write y is equal to, taking the integral of 2x dx. So we add 1 to the exponent, so that becomes a 2. So we have 2x squared. Remember, we take the exponent and put it down into the denominator. Don't forget the c. Okay, don't forget the c. And so therefore we have our solution is x squared plus. So we're doing some Cal 1, And we're talking about antiderivatives and indefinite integration, and so that's basically what we're going to be doing here is some indefinite integration. Anyway, I've got some problems here written out that we're going to solve. We're going to find the indefinite integral of the following. So you notice it doesn't say y is equal to. I just kind of left that part off. And we're just kind of focusing on this piece here. So here's 3 problems that we're going to work. So maybe you should try writing those down and working this stuff out maybe before I do and see what you get. All right. Okay. So for the first one, we are finding the indefinite integral of x plus 1 dx. So this is equal to. So we add 1 to the exponent. And remember, we take the exponent, put it down into the denominator, plus, and of course we have a 1 here, so we're going to add an x. Now think of it this way. If you took the derivative of x, what do you get? You get 1, right? And if you take the derivative of x squared over 2, you should get back x. So remember what this is, what that is called right there. That's called the integrand. And remember, if you leave off this c right here, this problem is wrong. Okay, so we always want to write the general solution. All right, the next one we have x squared plus 1. So we're taking our time learning this stuff real slow. We have x raised to the second power, so we're going to add 1 to the exponent. That gives us a 3, and of course it's over 3, and then of course we take the integral of 1 and we get back x plus c. So remember, you take the derivative of this and you should get back x squared plus 1. So that's the good thing about doing integration. You can always take the derivative and check your answer. Plus x dx. Alright, so we're going to have x to the 5th over 5 plus, and then of course this is going to be x, remember, add 1 to the exponent, over 2, and then plus c. It's that simple. And you know something? We got lots of time. Let's work some more. Let's say we had the integral of, let's say, x to the half minus 3x, let's say, and then plus 7 dx, and I'll just continue this down here. So we add 1 to the exponent, and of course adding 1 to the exponent is going to give us 1 over 1 is 3 2/3, or 3 halves. So you'll have to freshen up on your fractions there, and take the 3 halves and put it in the denominator. And actually, if you're a business major, you probably are going to be refreshing up on your fractions. Add 1. I couldn't tell you how many business majors that took survey to calculus that I've tutored over the years, and getting those fractions back fresh in their mind was a struggle for a minute or two. Okay, and of course, what are we going to do here? We're going to put the 2 up front and bring the 3 down here, right? So it's just the reciprocal. Flip this thing around, and then minus 3x squared over 2 plus 7x plus c. But I promise you, by the time you leave Cal 1, if you survive, you should get that stuff down. Okay, what about this one? Well, a lot of times we have to rewrite it, and so this becomes x to the negative a half dx, and then we go from there, right? Taking the or adding 1 to the exponent and so forth. I'll let you work that one out. Hopefully you can get that worked out there and get the answer. Remember. We're working antiderivatives and finding actually solving finding indefinite integrals. And I've got some listed down here that we're going to work. Of course, this is a continuation of my last video. I'm going to go ahead and work this one out. And so what you ought to do is just to write these down and try to work these things out before I do. So pause the videos, write them down, and see what you can do. All right. By the way, math is not a spectator sport. You got to jump in and play the game if you're going to learn. That's just all there is to it. All right, you got to move that pencil, you got to push that lead. All right, let's get busy. So this is a continuation of this previous problem that I had put up, and I believe it was 1 over the square root of x dx. So what we're going to want to do here is we're going to want to rewrite it first, and we'll do baby steps here. So this is x raised to the half power times dx. I think I'll just continue it over here. And then we want to take this up into the numerator, so this becomes x to the negative a half dx. And now what we're going to do is add 1 to the exponent. So adding 1 to a negative a half gives me a positive a half, right? And then we take the positive half, okay, put it down into the denominator, and don't forget the c. Don't forget the plus c there. And we want to get rid of this fraction in the denominator, so it just becomes 2x to the half plus c. So remember, we're going to do a little side work here. This is 1 over a half. You can actually rewrite this as 1 divided by a half. And then remember, back in kindergarten, we flipped this right here, 2 over 1. And so this becomes 1 times 2 over 1 just becomes 2. Okay, little side work. That's the stuff that usually slows everybody down. So anyway, there's our general solution. Man, I got a lot of them to work here in no time. All right, so we got the integral of 1 over x cubed dx, and we want to rewrite that as x to the 1 or x raised to the negative 3 dx. And now we just add 1 to the exponent, so it becomes a negative 2. Wow, I almost forgot that. Over, and then we take the new negative 2, put it down in the denominator. Remember, don't forget the c, the plus c there. So now we want to rewrite this with positive exponents. So we're going to take the negative and bring it out front. And of course, the 2 stays down here in the denominator, and this becomes x raised to the second power, and don't forget the plus c. And of course, remember, all of this stuff is equal to the 1 over x cubed dx, right? Okay, and remember, you take the derivative of this, and hopefully you get back to the integrand. All right. Where are we at? Ooh, here's a tricky one here. 1 over x times the square root of x dx. So we'll need to rewrite this as 1 over x times x to the half dx. And of course, we're going to need to add the exponents here. And we have 1 over x to the 3 halves dx. And now we're going to take that into the numerator, so we have x to the negative 3 halves dx. And ooh, we got to really get our fractions down, don't we? And so we add 1 to the negative, let's see, negative 3 halves. So this becomes x to the, let's see, add 1, I think that's a negative a half, right? God, I'm just guessing now, but because that's a negative 1.5, add 1, yeah. All right, plus c. And then we want to rewrite this, bring the negative out front. Of course, you're going to bring the 2 up, and then this becomes, and you know what, I'm just going to skip all those steps. That's the square root of x. Because this is x raised to the half power, we want to get it back into radical form. Oh, we're not going to finish. I'm not going to finish. I only got 5 minutes, and I'm not going to finish. All right, we'll continue this on. Hey, we're working the examples and finding indefinite integrals. Okay, so I'm continuing that problem set that I showed earlier. This is x times, we're going to put a parentheses here, x cubed. So this is kind of a quiz for you. You should pause the video and try to find out what this is equal to. Pause the video and get the solution, come back, and I'll have it worked out for you. All right. And if you don't want to do that, I guess just watch me work this out. So the first thing I'm going to do is rewrite. I'm going to rewrite all this. I should actually put an equal sign here instead. So this becomes x to the fourth plus 3x dx. And we'll just continue to put equal sign there. And now we can actually take the integral, and so we add 1 to the exponent, placing the exponent down below, and add 1 to the exponent, placing the exponent down below, and don't forget the plus c or it'll be wrong. Okay, so don't forget that. Alright. Oh, maybe you were working it out and now you need to see the answer. There it is. Okay. I try to work this stuff slow enough so you can work right along with me. Alright, we have 3x, and it's going to be squared times the dx here. Now, I'm going to go ahead and rewrite this. Still an equal sign because it's going to be equal. There's a couple different ways you can do this. You can go ahead and distribute that 2. So this would becomes 3 squared and then x squared, and then of course, right, all 1's over all of it. And then we can rewrite it again, and we're going to end up, now here's something actually I haven't mentioned. Let's say I have this, 3 squared is 9, right? 1/9 times 1 over x squared dx, and we have the integral sign written here. Now there's something you can do. These are some rules here. You can take this 1/9 and just bring it out front and get it out of the way, in front of the integral sign. Yes, I don't think I've mentioned that yet. Of course, we're still rewriting. Let me just go ahead and just rewrite it over here. Taking that to the top, so we have negative 2 dx. Rewrite that 1/9 times, now we add 1 to the exponent. Well, I tell you, this is where confusion comes in. It's like, do we subtract 1 or add 1? We add 1. Differentiation, you subtract 1, okay? Alright, so this becomes negative 1 over negative 1 plus c. Yeah, that can get kind of confusing. Now I'm going to take the negative and just bring it out front. And of course, bringing this back down, plus c. Now remember, we can always check our work on this now. I'm going to go ahead and just rewrite this. This is negative 1 over 9x plus c. So if we were to take the derivative, let's say we were to take the derivative of this. Let's just do that. Do I have time? Maybe if I do it quickly. Okay, in other words, I'm having to rewrite this. Okay, so we're taking the derivative of this. Subtract 1 from the exponent, or no, wait a minute. Take the negative and bring it out front. Whew, it's confusing. Makes that a positive x to the negative 2. It's over 9, and of course that's 0. And that ends up being 1 over 9x squared. Right, and I believe that's what we, that's what we started with. All right. Doing some Cal 1, and we're finding indefinite integrals. There's a tricky one there. We got the integral of dt. You know, that's kind of like something you'd see on a test, I promise. And a lot of students, believe it or not, would miss it, so that's the reason I threw it up here. And we got the integral of 5 dt and the integral of all this stuff. So you ought to try pausing the video and getting the solutions to these guys, coming back, and let's compare answers. So we start with the integral of dt. Now, there's a 1 in here. Okay, so this is really the integral of 1 dt. So don't let that confuse you. All right, the variable of integration this time is t. So I've been using the variable of integration as x. So, you know, in class, the teacher may work out a bunch of, the variable of integration may be x, and all of a sudden on the test you see a t and you're like, whoa, what the heck's going on there, Nelly? Okay. Well, it's just really this simple. It's just t plus c. Now remember, you can take the derivative of this and you should get back 1. Okay, take the derivative, get back 1. All right, what about the integral of, what was 5, I think it was, 5 dt. So this just ends up being 5t plus c. Right, so we can take the derivative of this and get back 5. All right, let's go and now work some more serious problems, even though I guess those could be serious if you were to miss them on a test. But a more complicated problem, I should say. Let's see, x squared plus x plus 1, and it's all over the square root of x. And you're probably saying, oh my God, I'll never get that right on a test. Sure you will. First thing we got to do is rewrite this thing. So I'm going to, of course, break this up. And then I'm going to, let's see, get that out of radical form, get it into exponential form, plus x over x raised to the half power, plus 1 over x raised to the half power. Let's put some brackets around everything. I could have put parentheses, it doesn't matter. And then of course we have dx. So we're still rewriting this thing before we can actually do an integration. We're going to bring that to the top. So this is x squared times x to the negative a half plus x times x to the negative a half, and then plus x to the negative a half. Let's put parentheses around everything and a dx here and the integral there. All right. Well, we're getting there anyway. Adding exponents. So we have 2 minus a half. That's going to be x to the 3 halves, right? I'm thinking that right. Plus x to the half. So we hadn't done any calculus yet. We've just been doing a bunch of algebra. And that's usually the way calculus is. You spend most of your time doing algebra. Ugh. All right. Okay, finally we've gotten somewhere. I should have been writing equal signs out here to the left. So what do? We add 1 to the exponent, right? So this becomes adding 1 is 5 halves. And then of course we put the 5 halves down here, plus add 1 to a half, and you get what do you get? 3 halves, right? Plus, and then we add 1 and you get half, and then put the half down here, and then plus c. Alright, well, let's do some stuff. So we're going to flip that fraction. That's 2x to the 5 halves over 5 plus 2 over 3 times x to the 3 halves. Now you notice I rewrote that differently, but that's okay, it doesn't matter. And then 2x to the half plus c. And then you probably want to get this into a radical form and out of exponential form, and I'll let you figure that out. That's a 5 right there. Man, what is going on? Okay, so good luck. This time we're going to be looking at some trig functions. So you're going to have to do some memorization on these guys. But we're going to incorporate some stuff that you've already learned. Right? So let's get busy. Well, you remember back when you were learning derivatives. I'm just going to go ahead and talk about this here real quick. And let's say we had y is equal to sine x. And we wanted to find the derivative of this, or y prime. So remember, we had to memorize that the derivative of sine x was cosine x. Yes. So what happens if I have the integral of cosine x dx? What is this going to be equal to? Now remember, we talked about this earlier. Okay. Well, this is going to be equal to sine x. But this time we got that constant of integration here. So if we were to take the derivative of sine x, we should get back cosine x. See that? Remember, here's our sine x. We take the derivative, we get back cosine x. So you'll have to remember that the integral of cosine x is sine x. But what about the integral of sine x dx? The integral of sine x dx is equal to negative cosine x plus c. So if we take the derivative of cosine x, remember the derivative was negative sine x, so that negative and the negative will cancel out and you'd just be left with sine x. So you're going to have to memorize these guys, the integral of cosine x and the integral of sine x, right? I know this could be confusing right now, but man, the only way you're going to learn this stuff is you're going to have to work a lot of problems. Okay, and once you do, you'll get it down, I promise. T squared. This time the variable of integration is going to be t. We have t squared minus cosine t, and then let's say minus 5 sine t, and let's put a parentheses around everything, and this will be dt. So we're going to incorporate some of the stuff we've already learned plus what we just got through learning, right? So put an equal sign here. This is being continued down to this line. We add 1 to the exponent, so this becomes t raised to the third, and it's over 3. Now what is the integral of cosine t? Right, it is sine t minus, and then of course we have this 5 here, just go ahead and rewrite it, and the integral of sine is negative cosine t, and then of course we got the plus c out here, and we're going to go ahead and rewrite this again, minus sine t, and we have a minus, and a minus becomes a plus, 5 cosine t plus c. Now remember, we can always take the derivative of this and check our work. Highly suggest it. Alright, so if you took the 3, brought it out front, the 3's on the top and bottom cancel out, and you got a t squared. Taking the derivative of sine t, remember that the derivative of sine t was cosine t, so there's our cosine, and the derivative of cosine t here was going to be a negative sine t. Negative sine t, so that would make that a negative. Alright, so you can always take the derivative of your answer and see what we get back. Hopefully we get back the integrand. Alright, moving right along. Well, I just noticed something when I went back to the original page. The problem, I think on the original page, this was a plus sign. Okay, it's a plus sign. I put a minus here, but it doesn't matter. This is the problem here that we're working out, okay? So there you go. All right, well, let's look at some more trig functions. And this time we're going to be taking the integral of secant squared x dx and the integral of secant x tan x. So here's some others that you need to you're going to have to memorize. So we have the integral of secant, I forgot this, I forgot the s, secant squared x dx. So just like memorizing cosine x and sine x, we need to memorize this one here, and it is tan x. Now the best way to memorize this stuff is to write it down. In other words, work some problems. I'm telling you, I've been down all these roads, and these are the best ways to memorize formulas. You just write them down. Work problems out. That's what I mean. Don't do a bunch of memorization. Actually work problems out. Here's another one that we need to memorize, and this is going to be secant x tan x, and of course that's dx. I think I ran out of some room there. I don't need to put that in parentheses, but the integral is going to be equal to secant x, and don't forget the c. So now let's work some combinations of these. So we have the integral of, and of course we're going to revisit some, cosine x minus sine x plus secant squared x dx. All right. So we want to find that integral. Whoops, there went the answers, or part of them. Okay, so what is the integral? Do you remember what the integral of cosine x is? And of course, I'll just go ahead and write it down for you. It is sine x, right? Minus, now what's the integral of sine x? It is going to be minus cosine x. Now you notice I started this with a parentheses and put the minus sign right here. I kind of suggest you do that. And then remember what the integral of secant squared x, it is tan x, and then remember this, don't forget the c. Right. So we're going to go ahead and rewrite this. This is sine x. A minus and a minus becomes a plus. That's the reason I wrote that in there. So you have cosine x plus tan x, and then plus c. I think I've got a little bit of time left to work another one here. We have the integral of secant squared x plus secant x and tan x. So if you're taking notes, you got to be able to get this one. It's supposed to be a t right there. Man, that just turned into a nightmare. And then a dx. So this is equal to, so the integral of secant squared x is tan x plus, and the integral of secant x tan x is secant x plus c. Secant x plus c. Alright, so we've got, we added two more to our list, and of course I'm just going to kind of work my way right down a list I've got written in front of me. And I think we're going to be taking the integral of cosecant squared, cosecant squared x dx, and we're going to take the integral of cosecant x, cotan x dx, and then the integral of e to the x, and yada yada yada. Alright, yeah, the integral of e to the x, the integral of a to the x dx, and the integral of 1 over x dx. So write all that down and work on it. Alright, I'm going to work some examples. So we're working Cal 1, doing some indefinite integration, and of course we're adding to our list. We're going to be finding the integral of cosecant squared x dx and cosecant x times cotan x dx, the integral of e to the x dx, the integral of a raised to the x dx and the integral of 1 over x dx. So these are some more that you're going to have to memorize, and then we're going to incorporate them into some problems in the next 10 more minutes after this video. Alright, we got the integral of cosecant squared x dx, so you definitely want to write these down if you don't already have them, is negative cotan x. Now remember, don't forget the c. Don't forget the c. Right, so write that down. We're going to be utilizing all these. Cosecant x times cotangent x dx, and that's going to be equal to negative cosecant x plus c. And then we're going to have the integral of my favorite, e to the x dx, and this is kind of amazing here. And the integral of e to the x dx is e to the x plus c. It's an amazing number, e is. Now remember, if you took the derivative of e to the x, you just get e to the x back. So that's an easy one to remember. We have the integral of a is some number raised to the x dx, and that's going to be equal to 1 over the natural log of a times a to the x plus c. Okay, so you got to remember how to take the derivative of a raised to the x power, right, in order to get back the integrand here. Alright, one more that's pretty important. That's going to be 1 over x dx, and that's equal to the natural log of the absolute value of x plus c. So need to write all those down, and basically, unfortunately, I hate to have to say this, but memorize that stuff. Alright. Okay, let's actually work some problems here. What about the integral of 1 minus cosecant t cotan t? I don't think I worked any of these. I hope not. I hope I'm not doing something I've already done. Oh Lord. Alright, the variable of integration is t, so the integral of 1 is going to be just t. Okay? And now the integral of this guy here. So remember, this is a minus sign. We're just going to carry this down. I'm going to start a parentheses here because this is actually the integral of this piece right here is one of those ones you got to memorize. And we end up with t plus c. And so we're going to rewrite this. We have a minus and a minus here, or a negative. That's going to make that a plus. And rewriting t plus c. So hopefully you're catching on. Oh, look at this guy here. He popped up out of nowhere. So this is 3x to the third over 3 plus, now remember what the integral of e to the x is. It's just e to the x, right? So this becomes 4e to the x plus c. And of course we can always take the derivative and check our work. Alright, so this time the theta, we're working with theta here. So the integral of secant squared theta is going to be tan theta minus, and the integral of sine is, remember, negative cosine theta plus c. Alright, we're working indefinite integrals. Okay, this one here, this is secant x, and then you can see there's a parentheses right here and then a closing parentheses here. So this is secant x times, and in parentheses we have tan x minus secant x, and of course then we have our dx. Alright, so that one's not going to be too bad. This one here we're going to have to use a trig identity, Pythagorean identity actually, to rewrite this. But this is just tan squared theta plus 1 d theta. Alright. So let's go to the board and work this stuff out. So our first one is the integral of secant x, and then I'm just going to put a bracket here so it's clearly defined. We have tan x, tan x, not theta. Sorry, that's an x right there. Minus secant x. Oh my god, why did I do that again? I don't know. I got theta on the mind. I think in the next problem I'll use theta. Alright, dx. So what we're going to need to do is distribute this secant x across. Alright, so I'm going to write equal sign here. So we're going to have secant, oh no, it's getting kind of ridiculous, tan x, 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 x. I wanted to write theta, I don't know what's going on with that. Secant of x times secant of x, there we go. And then I need to close all this in here. And then we have our dx. Alright, so secant x times tan x, right? These are one of those ones you're going to have to remember. Secant x times tan x is just secant x. Right, and minus, now figure out what that is. That's secant squared x. Okay, these two together, secant squared x. And the integral of secant squared x is tan x. Right, tan x. Then of course we got our plus c. My goodness, I'm using theta this time. That's just the way it's going to be. Alright, we got the integral of tan squared theta plus 1. And let's put that in parentheses, d theta. So we're going to need to use a Pythagorean identity, and that is that 1 plus tan squared theta is equal to secant squared theta. Right. Okay, so we just want to solve for tan squared theta here, and what we end up getting is tan squared theta is equal to secant squared theta, and then bringing this 1 over to the other side, minus 1. So we're going to do that substitution, secant squared theta minus 1. So we have the integral of secant squared theta minus 1, but then we have this one here, so plus 1 d theta. And we can rewrite this again. This is secant squared theta, right? Because those are going to cancel out, d theta. And of course, this is one that you had to have memorized, and that's going to be tan theta. And don't forget, plus c, right? So the key was to we needed to remember, we can't forget our trigonometry. It's very important that this identity right here, forget the identity. Alright, I believe this is going to be the final problem that I work in this particular hour here on part 1 of these antiderivatives and indefinite integration. I hope this at least gives you a basic foundation of how to get started in doing integrals. And I'm sure probably in the next section I'll work some application problems or word problems, however you want to state it. Anyway, let's just go ahead and do this last one since we haven't worked something that involved the natural log here. We've got the integral of e to the x over 5 minus 5 over x plus 3 raised to the x power. Let me write this out if I can remember it. It was the integral of e to the x over 5 minus 5 over x, and then I think I had plus 3 raised to the x power. Dx. Well, I think we worked one that involved e, but if you remember that the integral of e to the x is just e to the x, and of course this 5 down here is not going to matter. The reason for that is I'm going to actually do something, since this is the only problem I'm going to be working. The properties of integration, which I'm not sure I mentioned yet, but we can actually rewrite this. We can break all this stuff up if you would like. And then plus the integral of 3 to the x dx. So we can break all this up and do these all separately. And so remember, this is really the integral of 1/5 times e to the x dx minus, and this is, we could also say this is 5 times 1 over x dx. And of course this is not necessary in working this problem, but I thought I would show you that you can do this. And so you would take this coefficient and bring it out front of the integral sign, which now we have e to the x dx minus, I'm going to bring this 5 out front, and there's not much more we can do there. That's just 3 raised to the x times dx. Of course, we need to throw an equal sign out here since they're all equal. Alright, so the integral of e to the x dx is just e to the x. And of course, we got this 1/5 out front. We want to make sure we rewrite that. Now, the integral of 1 over x is the absolute value of the natural log of x, right? The absolute value of the natural log. The natural log of the absolute value of x, however you want to say that, plus, now you take the natural log, you're going to be taking the natural log of 3. Okay. And then we just end up rewriting 3 raised to the x, and of course you shouldn't forget this, the plus c. Don't forget the plus c there. You could rewrite this piece right here if you'd like as 3 raised to the x over the natural log of 3 if you wanted to rewrite that. Of course this could be rewritten as e to the x over 5. I guess I should just go ahead and finish the whole thing. The natural log of the absolute value of x plus, and then plus c. Alright, so once you get good at this stuff, you don't really even have to do all that. You'd skip a lot of steps. You just go from there to the answer, you know. But I just want to show you that you can break all